Welcome to EOC Tutorials Week 4. This week we're going to be studying exponential functions. Today in particular we're going to be looking at the graphs and we're going to be identifying the domain, the range, the y-intercept, the asymptote, and talking about what the a and b represent in terms of the function. So let's get started. Here we have a scenario. A certain type of bacteria doubles in population every hour. When we begin looking at the sample, there are 16 bacteria. So first, let's draw a function from this situation. So we know that there are 16 bacteria when we start looking at it, and we know that it's doubling every hour. So our function would look like this. F of x equals 16 times 2 to the x, 16 being that starting amount, and the doubling being represented by 2, and the x is in the exponent because it's every hour. So we're doing repeated multiplication, which means we're using exponents. Now let's look at the table of values generated by this function. So we started at 0. That's when we began looking at it, and we had 16 bacteria. After an hour, it doubled, so 16 doubled is 32. The next hour, it doubled again, so now we're at 64, and doubled again for 3 hours, 128, and 4 hours, 256. But there was 16 bacteria when we started looking at it. Obviously, things were going on beforehand. It didn't just suddenly start doubling. So let's look at some back in time values as well. So an hour before we started looking at it, there were 8 bacteria because an hour later they doubled into 16. 2 hours before we started looking, there were 4. 3 hours before we started looking, there were 2 bacteria. And 4 hours before we started looking, there was only 1 bacteria. Let's go ahead and plot this information on a graph so that we can start analyzing and looking for those pieces we were talking about. So we'd have these points, and if I were to sketch a line to connect them, it'd actually be a curve, not a line. It would look something like this. Okay, so first thing that we wanted to talk about were domain and range. The domain would be the x values that we're interested in, and you'll notice that we don't have any gaps anywhere. We go all the way from this -6 to the +6, and there's no limitation. We could keep going, and we would use all the numbers. Now, technically speaking, because I'm sure there's some of you out there going, wait a minute, at 4 hours before we started looking, there's only 1 bacteria. If we go any further back in time, we're not even going to have a whole bacteria, and that doesn't make sense, and you're absolutely correct. But if we're just talking about the function, then we would have that option. Being locked into the real life scenario, we do have some limitations, but just talking about the function, technically speaking, we could plug in any number for x and get a value that goes with it. So our domain is all real numbers. Now for the f of x, the range values, the y values, looking at the graph, I see something real obvious. I don't see any negative y values used at all. Now the question is, over here, does y equal 0 or does it not? Well, let's think about it. If we were to go to -5, then that would have been 1/2. And if we went -6, that would be 1/4. Could we keep going further and further into the negative numbers? Would our function ever actually equal exactly 0? The answer is no. It'll get really, really close to 0. I mean ridiculously close to 0. But it's never ever actually going to equal 0. So our range values are going to be y strictly greater than 0. Anything that's above 0, y can be that value. That y never equaling 0 leads to a phenomena in math graphing which is called an asymptote. An asymptote is it's a number that you get really, really close to, but you never actually land on. So this one has an asymptote of y equals 0 for exactly what we just talked about. We're going to get ridiculously close to it, but it's never actually going to equal 0. So that's a line that's approached, and so that's called an asymptote. The other two things that we need to know about a and b. When you're in your function notation right here, this first number is a, and the second number is b. So our 16, you'll notice that was our starting amount. On our graph, it was 0.16, or excuse me, on our table, it was 0.16. On our graph, that is the special point, the y-intercept. And that's one that people are usually pretty interested in knowing about. So the a value is your starting amount, also known as your y-intercept. When x is 0, y is 16. The b value is the 2. And so this is telling you how quickly your your function is either growing or decaying. In this case, it's growth. It's doubling. It's very obviously getting bigger, bigger, bigger as we go left to right. Anytime your b value is greater than 1, it's going to get bigger. If it equals exactly 1, it's not going to do anything cool at all, because when you multiply by 1, not much happens. Okay, let's look at what happens when your b is between 0 and 1. That's going to be a decay situation. So for tax purposes, business assets like a computer depreciate, which means to lose value, by 20% each year. And that's not just me making it up. That's in the actual tax documents. When you have a company and you file your business taxes, they will say that your company assets depreciate by 20% each year. That's what they allow. So today, your company computer is worth $300. Let's go ahead and write the function that goes with this scenario. So it'd be f of x equals what we have today, $300, times 1 minus 0.20 to the x. This 1 minus 0.20 is the value that the computer has, and we're depreciating, we're losing value, so we're taking away 20%. And you'll notice that we switched 20% into a decimal. If you want to simplify the inside of the parentheses, you would end up with the second version there. It's just a simplified version of the first. F of x equals 300 times 0.8 to the x. Generating a table of values, you'll see that right now it's worth 300. Next year, 1 year later, I get to depreciate, take off 20%, so it's worth 240. The following year, 192. 3 years later, 153.6. 4 years later, 122.88. Again, that's what my computer is worth today. I didn't actually buy it today. I bought it sometime in the past. So let's look at what it was worth. So a year ago, it was worth $375 according to the government. 2 years ago, it was worth $468.75. 3 years ago, it was worth $585.94. And 4 years ago, it was worth $732.42. Let's plot these points and see what's going on with the graph. This time, instead of going up, up, up as we go left to right, these are going down to down, down, down. And if we connect our points, we see we've got a nice downhill curve. It's not nearly as steep as our other one was. So let's identify those key components again, the domain and range. Domain, again, it's going to be all real numbers. We could keep going back in time. Technically speaking, there was some point that we actually bought it, but if we're just looking at this function, we could go back in time as far as we wanted, and we can go forward in time as far as we wanted. So domain's still all real numbers. We can tell that our computer is definitely losing value, but again, it's never ever going to hit exactly 0. Now, I'm not saying that your computer is not going to be worthless at some point, because we know technology does not hang around forever. But technically speaking, according to our tax document, you would never have a value of flat out 0. It would get really, really close to 0. And again, you'd probably throw it away before it got there, but it's never going to equals 0. It just approaches it. So our range would be y is greater than 0. And because we're not landing exactly on 0, we have that asymptote relationship that we were talking about before. Y equals 0 would be our asymptote. The last two things that we wanted to talk about are our y-intercept, which is 300. Remember, that is the a value of our function. And in our word scenario, that was our starting amount. In our table, it is when x is 0. And then the other thing is our b value. We know that we've got decay. It's going downhill as we go left to right. And notice that our b value this time is between 0 and 1. That's because we took the value of the computer, the 1, and we took away 20% each year. So 1 minus the 0.2 gives us a value between 0 and 1. So we're going to have decay. So that's all that you need to know today about exponential functions. Soon we will be doing more with them, but I hope you found this useful and you're able to do the rest of the activities. Thank you so much and have a wonderful day.